Now, the topic which we are going to see is the electromagnetic wave in a matter. That is, when an electromagnetic wave is traveling through a different medium, what happens to this electromagnetic wave equation or wave propagation? Will it will be the same through that behavior is same or the behavior is different? That is the thing which we are going to see through that. So we are thinking that anything having a mass and occupy a space is called we all know that a matter. Matter will have it is in a three phases. One, it is solid phase, liquid phase, and gas phase. So the behavior of electromagnetic propagation is not same in all the material medium. It is not same in solid. It is not same in liquid. It is not. It is not such of a solid and liquid. That is, gas is not such as a solid and liquid. So it is based on the characteristics of that material's medium. That is the characteristics of the medium through which the light is propagating. If the light is propagating to the solid medium, it will be non-form. If the material is propagating in a liquid medium, it will be its behavior is different. If the electromagnetic wave is propagating to the gas medium, its characteristics also it varies. So mostly the regularly used material mediums are conductor or non-conducting material. So here we are going to discuss about behavior of wave propagation and its properties in any one of the material medium such as dielectric medium, and also we are going to compare it with the vacuum when the light is traveling through the vacuum. That is the difference between electromagnetic wave in a vacuum or a free space and when an electromagnetic wave is traveling in a non-conducting or dielectric medium. So here we are going to first see about a plain electromagnetic wave. Here, if the field vector of an electromagnetic wave is constant or a plane, that is perpendicular to the direction of propagation, then we are calling it as a plain electromagnetic wave. Here, the plain electromagnetic wave which propagates through a propagates through a linear isotropic medium or homogeneous dielectric medium. This is a thing we are going to compare. In a plain electromagnetic medium, that is in a vacuum, we can say that permeability is mu naught, permittivity is epsilon naught. That is a permeability of a free space and permeability of a free space are a vacuum or a constant, and electrical conductivity sigma is equal to 0. Similarly, in a non-conducting or a dielectric medium, permeability is mu and permittivity is epsilon and conductivity is sigma will have a constant value. But for an isotropic dielectric medium, we can say that sigma is equal to 0 for a perfect dielectric medium. So if the medium is assumed to be the charge-free medium, then we can write that charge density rho is 0. Similarly, here also the medium is charge-free, the rho is equal to 0. So first, the Maxwell's equation for free spaces, del vector dot E vector is equal to 0, del vector dot B vector is equal to 0, and del cross E vector is equal to minus dou B vector by dou t, and del cross H vector is equal to epsilon naught into mu naught into dou E vector by dou t. So it is similarly on a non-conducting medium, instead of wherever there is an epsilon naught mu naught, it should be replaced by epsilon mu. So this is a wave equation in terms of electric field, and this one is in terms of magnetic field. Now we are going to take a curl on both the side of equation 3. When we take a curl on this one, what happens? Del cross E vector is equal to del vector cross of minus dou B by dou t vector. So according to vector identity, when you substitute this one, it becomes del vector cross of del cross E vector is meaning is it is equal to, we bring this dou by dou t outside, minus dou by dou t of del cross B vector. So instead of del cross H, you substitute the equation 3, and instead of let it be as that is here substituting this equation 4 in 5, what happens? Del cross E vector is equal to dou minus dou by dou t of del cross B. So here substituting the equation 4 in 5, del cross B vector is what? Epsilon mu into dou E by dou t. So here, since it is a free space, epsilon r and mu r is equal to 1. So del vector cross of del cross E vector is equal to minus dou by dou t of epsilon mu naught in epsilon naught mu naught into dou E by vector by dou t. Similarly, this side. So del vector cross of del E vector is equal to minus epsilon naught mu naught into dou square E vector by dou t square. Using the vector identity, we can write that is the del cross of del cross A vector is equal to del into del dot A minus del square A vector. This is the vector identity. When you compare these two, this is these two equation. Here we are comparing these two equation. We are substituting this vector identity in the equation 6 on both the part. So when we compare these two, it becomes del into del dot E minus del square E vector is equal to minus epsilon naught mu naught into dou square E vector by dou t square. Similarly on both the side. What is del dot E? That is Maxwell's equation in terms of free space, it is equal to 0. And also in a dielectric medium also it is equal to 0. So the first part of this one will become 0 and minus del square E vector is equal to minus epsilon naught mu naught into dou square E vector by dou t square. So this equation represents the wave equation in terms of electric field in vacuum or free space. This right hand side represents the del square E vector minus epsilon mu into dou square E vector by dou t square is equal to 0. No? It is the wave equation in terms of electric field in a dielectric medium. Similarly, we are going to prove it for a magnetic field. What is magnetic field? We are considering the fourth equation. Del cross H is equal to del vector cross of epsilon naught mu naught into dou E vector by dou t. So this del cross of del cross E is what? Del into del dot B minus del square B is equal to, here del cross E is what? It is taken as del cross E is equal to minus dou B by dou T. So substitute this one. When you substitute it, it becomes del cross of del cross B vector is equal to minus epsilon naught mu naught into dou square B vector by dou T square. This is on both the side. When you substitute this value in the above equation, when you substitute this one in above part, it will become, this is the vector identity. This vector identity, when you substitute, it becomes del vector of del vector dot B vector minus del square B vector is equal to minus epsilon naught mu naught into dou square B vector by dou t square. The same thing happens over here also. Substituting the equation 12 in 13. So the del square B vector is equal to, here this term will become 0, is equal to minus epsilon naught mu naught into dou square B vector by dou t square. Similarly, on right hand side, we have the minus del square B vector is equal to minus epsilon mu into dou square B vector by dou t square. So this is the plain electromagnetic wave equation in a vacuum in terms of free space or magnet or in a dielectric medium.